Welcome, everybody. I'm Brenda Minyukwi, Director of Operations here at Raven AI, and I'll be one of your hosts for today's webinar. The topic of today's webinar is the missing piece for OEE optimization, automated contextualization. The term automated contextualization may be new to many of you, but don't worry, we're going to dive right into exactly what that means. Before we get started, I wanted to go over a few housekeeping items with you. The session is being recorded and our marketing team will send out a copy of the recording to you via email before end of day today. And Lindsay, our marketing director, is also online for technical support. So if there's any questions or issues throughout the webinar, please feel free to use the chat option and message her and she'll be able to help you out. And lastly, would love for you to join the conversation today. If you have any questions, please submit them in the Q&A box. How to access the Q&A box, right at the menu bar at the bottom of the screen. We've also set aside 10 to 15 minutes for Q&A at the end of our panel discussion today. So really looking forward to the engagement from all of you. For those of you that are not familiar with what Raven does, we work with manufacturers on their OEE and continuous improvement initiatives and help them enhance the day-to-day work of frontline teams with our automated contextualization and OEE improvement software. You'll quickly see how passionate we are about the work that we do and the technology that we provide as we dive into the conversation. So let's move on to the key topics for today. What we're going to cover is the state of manufacturing today. We'll discuss the critical gap on the shop floor, which is missing context. And we'll also kind of give you that overview of what the automated contextualization is. And then we'll end off with what challenges this actually solves for manufacturers today. So with that, I'm happy to introduce to you the other hosts for today, Dr. Paul Turner, who's the COO at Raven, and Martin Cloak, who's the CEO. Over to you, Paul.
Hi, everyone. So as Brenda said, I'm Chief Operating Officer at Raven. Previously to that, I was Vice President for Industry 4 Applications Analytics at Stanley Black and Decker. I've been in manufacturing for over 25 years, focused on process optimization.
Awesome. And I'm Martin Cloak, a co-founder and CEO of Raven. I'm a high-tech guy who was fortunate enough to spend the first 4 years of my career working on the shop floor of a manufacturing plant and learning what real life is like there. And that's part of the reason why I got myself into what we're doing at Raven. And I also spend a lot of time chatting about, what I'm most passionate about is using technology to enable sustainable continuous improvement. And then that's some of what we will chat about today. So I'm looking forward to the conversation.
Fantastic, Martin. And I think you nailed it there because my experiences are really being that person on the shop floor throughout majority of my career. So really excited about the work that we're doing here at Raven and engaging in this fantastic discussion today. So currently we talked about manufacturing quite a bit. So what is the state of manufacturing today? Martin, any thoughts on that?
Yeah, absolutely. And I think it's especially interesting for those of us who've sort of spent our lives in working in manufacturing and seeing that there's been a bit of a transition over the last little while. So, what it takes to successfully manage operations today is not quite what it was a few years ago. And there's a lot of market conditions that are leading to this. So today, because of supply chain volatility and labor force disruption, and the fact that all of us want highly customized goods to be delivered extremely quickly, the kinds of things that manufacturers are having to deal with is making it difficult to keep up with demand, let alone drive improvement. And these changes, although they were triggered by unforeseen events, they're here to stay. So manufacturers need to move away from a system where they are able to plan 1 week at a time to being much more nimble and able to deal with these sudden changes. So, what it takes for manufacturers to keep up is changing, and because of that, manufacturers are investing a ton in technology. And this makes a lot of sense. Technology, the promise is to be able to take data in from various systems and making it so that we're able to make smart decisions. So, in 2020, $120 billion were invested in Industry 4.0 technologies, and that's increasing at 30% every year. So tons of investment. One of the challenges is that for many manufacturers, they're not yet seeing the returns on their investments. And 4 out of 5 of these projects don't deliver what's expected. And one of the things that's most concerning is that close to 80% of manufacturers, and this is where if you go to the shop floor, don't trust the data from their data systems. And then this is a bit of a shocking stat here. The fact that 4 out of 5 manufacturers don't trust the data from their data systems is one of the reasons why many of these initiatives fail to deliver. But in some ways, not getting an ROI from a project is bad, but what's even worse is losing credibility on the shop floor. And this is something that you don't see in your Excel file, but you see if you've lived on the shop floor. You see it based on the looks on the face of people who have been asked to use technology. So manufacturers are now investing in tech. Tech isn't quite delivering ROI, and there's a challenge with creating that trust. And once trust is lost, it's hard to get back. So what's happened here? So if we think about what we're trying to achieve with data and manufacturing, the process to improve with data has been the same for a long time. It maps pretty closely to lean manufacturing principles. To improve with data, you need to capture data. You need to take this data and then understand what's happening now, what has happened in the past. Once you have that, you can dig in to understand why it's happened. Then when you understand why, you can predict what will happen. And then at the end of the day, if you want to actually drive improvement, somebody needs to do something. So this sequence of data collection, data cleaning, data analysis, and then action is one that we've used since the beginning of manufacturing. And now what we are doing to deal with the fact that we need to be much more nimble, we're trying to do this in real time. So now if we think about the kinds of things that we are really good at today in real time, we have never been this good at collecting data. We can collect data from anything. This is something we've been able to do in the past, but now with IoT, we collect a ton of data. We've never been this good at analyzing data. Now, the challenge is that between collecting data and analyzing data, there's a critical step that is very challenging and often underemphasized. And this step is to make sure that this data is clean, complete, and accurate. So that jump between data collection and data analysis is what we call contextualization, which is around how we pull in data from various systems and clean it. And this is the critical step. You cannot get value from bad data. And I think this is something that Paul will dig into later. And then once you have this actionable insight that's extremely valuable, you need to close that loop and get people to take action on the shop floor and do something. And people only do things if they're engaged to act. And I think these are, so in our space right now, plenty of coverage for collecting data, analyzing data. Where we struggle, and part of the reason why many of these initiatives are struggling, is that we have underemphasized as an industry cleaning data and creating engagement on the shop floor, which is what we obsess over at Raven. And this is something we'll dive into later. So I guess one of the biggest challenges with this now is that we have to deal with the challenges of the fact that our data is incomplete and inaccurate. And I'd love to throw this over to Brenda. And I know that earlier in your career, you worked as a CI leader, both at Mondelez and Kraft and at others. And I'm curious if you have any examples of when you've had to struggle with the consequences of having incomplete and inaccurate data, in particular, with people on the shop floor.
Thanks, Martin. And I'm smiling a little bit because it's almost like confessional times as you were speaking, right? It's exactly the script that we're following. So you're reminding me of, when I was training as a CI, in terms of my continuous improvement journey, it's the same script that we followed. And that's exactly what I did, right? So target the area where the waste is coming from. So it's usually, for example, it's the case packer where we're getting all the rejects coming out of. So I embarked on the value stream mapping exercise after quickly realizing that from my bird's eye view angle, I didn't really know where the areas of waste are coming from because we had that incomplete data. So I had to go back, engage the shop floor operators to get the context that's always missing, right? So operators always know. I will always stand true to that, is they know the equipment, they know the machines. And a lot of the initiatives that we tend to bring when it comes to continuous improvement, right? It's kind of top down. We're not engaging and collaborating in terms of what are the right tools.
So you're saying you started with data, I guess, from the PLC to start with, but then what you realized was that there was a missing context from the actual operators at the machine?
Exactly. When you look at examples like microstops, right? It's a lot of the times the operator sees it on a daily basis, but it's what is the cause, right? Is it because we went through a long period without having to do the maintenance and the piece of equipment? So that context is what happens is it took so much time for me to able to gain trust with the people on the shop floor, because I had to prove to them that I'm trying to action something that's going to make everyone's lives better. So the issue we end up having with manufacturers is, as we try to get the context, it's going to take a long time. And in a world of finite time and resources, it's something that we currently don't have. So I think when I go back to my example, it's, even all the tracking that we did, we had the fancy tools, we even, things like Minitab in terms of trying to analyze that data. But again, we're throwing a lot of resources onto some of these projects, which is also not sustainable.
There's an interesting question here about knowing, from the audience here, about knowing what problems to solve. And I think there is a difference between collecting data and what we actually want to do with data. So fundamentally, if we break down, what I mentioned before, all we are trying to do is make it easier for people to identify and solve problems quickly. So like that could be sort of to sum up what we're trying to achieve here. So if we're trying to identify and solve problems quickly, it's pretty clear when you're looking at data from these digital sources that you don't have enough information to get to the root cause. And that naturally brings you to the shop floor. And then when you hit the shop floor, what many realize, for those of us who've kind of gone from engineering to the shop floor, is that the data available to us from digital systems only captures the tip of the iceberg with regards to what actually happens on the shop floor. Data from these digital systems is highly effective at measuring performance, but not identifying the most important problems or the root cause of those problems. So there's that, and that's the realization that you don't get taught in engineering school. You only realize once you go to the shop floor and see people giggling when the young engineer comes to the shop floor.
And I think, Martin, too, it's a great point that came in from the audience there, because I certainly got caught up in chasing that number of, I want to deliver world-class productivity, right? So I had my percentage I was chasing, and you often forget to loop back to what am I actually trying to solve?
Awesome. So, I'd also love to loop in Paul. And Paul, your career has kind of spanned almost every different area of continuous improvement, from building technology to developing corporate strategies to working as a consultant. And I think I'd be interested in your perspective on the impacts of incomplete and inaccurate data on your last focus, which was at Stanley Black and Decker as VP Industry 4.0 in Analytics. And you were setting up global Industry 4.0 platform. So I'm interested in your perspective on the impact of incomplete and inaccurate data on your global initiative, specifically as it relates to people working in operations.
Good question, Martin. So if I just back up to the platform building, I guess companies in their quest to gather information to drive data-led decision-making, literally spending millions of dollars building cognitive platforms, AI platforms, hardware, software, connecting their assets, with that promise of untold value that's going to be delivered by AI and machine learning. However, as I think we've alluded to, there are two key barriers to these benefits that often get overlooked. And something that we definitely experienced in my previous incarnation. First is that engagement and buy-in from the operations teams. And then secondly, the context and accuracy of the data being extracted. Now, OEE productivity systems are typically built by engineers in order to deliver targeted productivity improvements that look great on paper. And then operations are expected to comply with the sort of standard work elements that are needed to deliver that value. But in many cases, that approach doesn't work. Operators expect technology to make their life easier. They don't expect it to task load them with additional standard work. And yet that engagement with operators is essential in order to get that accurate, contextualized data around the performance of the factory assets. So, as you said, Martin, in many of the factories, we may be able to pull some of that data on downtime reasons from a PLC or a sensor, but there are many downtime reasons associated with significant productivity losses where the reason isn't available in a digital form, and so it just gets classified as undefined or is unclassified.
I wonder just to focus on, because you said a really important thing, which is that operators expect technology to be useful to them. And in some ways, isn't that the definition of technology? Isn't the definition of technology sort of the practical application of science that it is inherently useful? And I think in some ways, the perspective of who it's useful to is miscast in some cases. So the technology, if it's useful to engineers but not useful to the front lines, that is going to actually impede productivity. So I think in some ways, if for organizations, especially those who abide by a servant leadership, what can we do to enable operators to perform? It's by giving them tools that enable them, that consume their inefficiencies rather than distract them and consume their time here. So in some ways, organizations would be best served to really come up with that clean definition of, what value the technology is applying to the front lines. And that's something that's often missed for those of us who started in engineering. And I think all three of us kind of started from engineering first and then got our experience on the shop floor. But that's a key thing here where, in order for technology to truly take hold on the shop floor, it needs to be obviously useful to the person on the shop floor. And that's often missed.
It's actually a virtuous cycle as well. Mm-hmm. So if we can solve that problem of getting the accurate, fully contextualized timeline for downtime, that provides the necessary data for operators to improve their performance significantly. And if they do that, then that in turn improves their compliance with interacting with the system. However, the opposite of that is if the system is poorly designed and it fails to automate as much of this process as possible, then operators will disengage, and that creates a poorly contextualized timeline, which again creates further disengagement. So the two things have to work together in harmony, both the technology and the operations teams.
I think, Paul, you're going back a little bit to my experiences there, right? Because that vicious cycle was my aha moment, because a lot of the times when we're focusing on productivity initiatives, right, we focus on that timestamp in that time. And, whether it's 3 weeks where we're trying to get that context off the production line, we throw on the additional resources so that we have that clean data, and we make a decision based on just that snapshot of the operations over a short period of time. So in my experiences early on, I can certainly own up to saying that I don't believe that a lot of my capital projects that were supposed to drive productivity actually gave us back that return of investment in the time frame, right? So to your point, Paul, absolutely, we end up being reactive versus proactive, because guess what? I promised more capacity, more output, higher quality, and the demand and supply planning teams started planning to, fill up that volume I'm bringing in the plant. So we end up repeating ourselves, right?
Yeah. And I think you introduced an interesting concept here, Brenda, where you said that you didn't believe that your initiatives actually delivered what you had expected. And I think that's a second component. And that actually, I have my experience sort of kind of links to that. And my early career personally benefited from poor data quality. And so I was working in the blinds industry. And in the blinds industry in Montreal in particular, the blind volume spikes in July because everybody moves in July. So therefore, the most blinds are sold in July. Now, the way that they measure quality and returns is how many blinds did I get back this month compared to how many blinds did I send out this month, which of course is not the right way to measure quality, because it takes time for stuff to get back. So I started on a quality initiative in spring, which was a perfect time. So I started in spring, started looking at certain things, and then volume began to pick up. So of course, my numbers started to look really, really good. And then at some point leading into the summer peak, I actually got singled out for good performance because my quality numbers were so good, and I actually moved on to a better project. But fundamentally, I cannot say if my efforts provided any value to this project. I maybe did something here. So, but I think what this highlights is that the impact of poor quality data results in getting engineering resources and investments into areas or in ways that don't provide any value. So one of the reasons why many of these technology initiatives fail, and the number is 81%, is that when you don't have a clear understanding of what's actually happening, and you're making decisions about where to deploy technology based on incomplete or inaccurate data, you may purchase or do a project that actually is very good technology, very good engineering, but if you assign them to the wrong areas, so you buy a robot for the wrong area, you invest in the software for the wrong area, you're not going to see returns, regardless whether or not the technology works. So our space doesn't suffer from poor technology. There's a lot of amazing technology out there. What happens is that we are still using gut feel to decide where to deploy this technology, and the way to move away from gut feel is to actually know what is happening, what has happened, why has it happened. And I think this is that stage, which is part of the reason why we're focused on that at Raven. So, to sort of sum up this section here, we've never been this good at collecting data. We've never been this good at analyzing data. Where we struggle is to clean it and then to engage on the shop floor. So I think this is a good opportunity to tee up our first poll. So the question I have for you folks in the audience is, what is your team's biggest barrier to continuous improvement today? So again, options are supply chain volatility. That's not getting better anytime soon. Labor shortages, once again, it's a challenge. Shortening lead times and increased complexity. So I'll give you guys a couple minutes here to answer this, and we'll look at the results together. And I'm curious, Brenda and Paul, which of those, don't influence the audience, but I'm curious which of those sort of is highlighted for you guys.
So how do we say what we think without saying what we think then, if we don't want to?
Well, you know what? Say what you think. You know what? At some point, if you want to persuade, like maybe we try and pitch the ones that we like the best or dislike the best.
For me, it's the increased complexity, right? Like I go back to I'm very consumer-centric and customer-centric, and people want better quality, they want things faster. So it's the complexity that's introduced with the people we need to serve.
Yeah, I would say agility and speed. So I'd actually try and tick the bottom two, but I think you can only choose one, can't you?
Interesting. I always gravitate towards labor shortages. I think that's one that, oh, okay, increased complexity. Oh, Paul and interesting. And I think the increased complexity is kind of around, as consumers, we all want things to be customized, and technology actually allows us to customize things. Our challenge is to basically just have data so that we can actually organize ourselves to deliver on time, which is, so the increased complexity is compounded with this. So interesting. Any comments, Brenda or Paul, about the results?
I think for me, it goes back to, when a lot of the initiatives I used to work with in terms of driving efficiencies in production is you need things to be steady state, right? So if you think about, production runs for a certain SKU, we would aim to say, let's just have a full production of that same SKU for the whole week, with their complexity and their consumer segmentation that's coming in, right? That's more challenging, where you have changeovers are becoming more frequent, right? So you really have to nail how you execute those operations. And it goes back, we need the context so we can know where to focus.
Yeah, without question. So actually there's a, I think there's a question that we'll jump on later, but no, without question, I think that the complexity is a challenge. And you sort of mentioned kind of the plan for the week. And many manufacturers today still have that plan for the week that they put out there. And then what happens is that the plan gets thrown out the window, and they're constantly having to jam in jobs out of sequence, which means that they're doing 5 times as many changeovers out of sequence. So you can't even optimize the order of changeovers. So changeovers are inefficient. So really the consequence of kind of having to jam in orders after the fact almost throws the initial planning out the window, which is part of the reason why complexity is so hard to deal with. Thanks to all of you who participated in the poll. We had some good, I believe 40 people responded. So now I wanted to tee up the next section. So kind of to dig in further into this sort of the critical issue of contextualization, or our ability to make sure that we have complete and accurate data. Paul is going to describe a little bit about what is contextualization. What exactly, how do we actually take all these different data sources together to truly understand what is happening now on the shop floor and what has happened?
Yeah, so get around some of the definitions. So first of all, what do we mean by a contextualized timeline? Because it's more than just knowing whether the asset is running or not. And it's more than just classifying whether there's an unplanned downtime or a planned downtime, or even an electrical or mechanical fault code pulled from the PLC. It's accounting for 100% of an asset's timeline to a sufficient degree of granularity that the losses on the plant can be identified, prioritized, and remediated through continuous improvement. So, for example, this includes material losses, losses associated with waiting for an operator or a maintenance engineer to attend an asset, problematic setups or slow changeover times are losses that that you can't necessarily get from a digital system. Even speed losses you could convert into the equivalent of a downtime loss in order to make sort of comparisons. Simple things like prolonged break time losses, a break that's scheduled for 5 or 10 minutes that lasts 20 minutes. There's a 10-minute loss there. And then I think most importantly, microstop losses. The last thing we want to do is ask an operator to continuously be tagging downtime reasons for microstops. That's how to definitely disengage an operator.
But one of the things you mentioned there in the types of losses is that a lot of them sound relatively mundane and are not the kinds of things that would typically be top of mind for manufacturers when they're thinking about what to drive improvement. So you mentioned waiting loss, so operators waiting for a resource. So what we see with our clients is that waiting loss is typically one of the biggest source of losses. But if you spend time looking exclusively at PLC data, you will think that machine reliability is an issue. So I think the fact that a lot of the losses that are actually holding manufacturers back are often these mundane losses, including inefficient shift change, waiting for resources, spending too long in setup, is often a surprise when they first see fully contextualized timelines. But then it switches over from surprise to excitement by the fact that addressing these can be done with known methods and typically with their operations team. So I just want to highlight that I think just the fact that these causes are often perceived as mundane is often a surprise to manufacturers.
Yeah, and I think misdiagnosis, like you say, mistaking an asset reliability issue for what is actually a resourcing issue, that's an example where poor or incomplete data leads to not just poor diagnosis, but poor prioritization, poor decision-making, and the whole continuous improvement strategy becomes inefficient. And actually, in the current environment, that could become existential for a factory's profitability potentially. So that's why it's so important, contextualized data for productivity improvement. So a question we often get asked, and Martin and I got asked this very recently, is, so why is it so difficult to contextualize downtime reasons? Surely we can just tell the operators to tag downtimes appropriately. Well, to do that in sufficient detail for what we've been describing, it's far too big a task for an individual operator. If it's done at all, then downtimes will just get aggregated into some uber catch-all category like undefined or unplanned downtime. Operations are very busy. And from personal experience, operators will just claim that, blame the software. They hate the solution. They don't have time. They'll blame the software and refuse to use it. And at that point, you've broken that virtuous cycle that I mentioned, and you've got that disengagement with operations. So where does automated contextualization help? Well, the first thing I'll say, it's a really important point to get across, is when we talk about automated contextualization, we're not just talking about some fancy AI algorithm that's automatically tagging downtime. Okay, what we're actually talking about is this sort of harmonious and symbiotic relationship between the algorithm and effective operator engagement for tagging those downtimes, where it's essentially impossible to tag automatically. And I'll steal one of Martin's examples that he gave earlier in the week to me. If we divide a 24-hour timeline into, say, 200 time units that need tagging downtime reasons, we may be able to say half, 120 of those units of them you could tag automatically through a PLC code or something read from the sensor data. It's the remaining 80 units that require some other mechanism and need some involvement from the operator potentially. Now, one approach, as I've said, is to get the operator to tag all of these 80 units. But for the reasons I've said, it doesn't work. It's too time consuming, and particularly if the stops are micro stops or if they're deviations from standards that the operator might not plug into. So what automated tagging does is it's not trying to tag all 80. Okay, it's trying to maybe tag 50, 60, 70 of the 80, and then just leaving the bare minimum for the remaining 10, say, to be performed by the operator. And this is where you get people and technology working in harmony together. So, for example, if during a setup the operator clicks on setup, that's one HMI interaction from the operator. However, if over the next 20 minutes the machine keeps going down, back up, back down with micro stops, you certainly don't want to be asking the operator to keep tagging while they're trying to fix what the problem is. The algorithm should do that automatically. Okay, so that's the relationship between automated contextualization, the operator, and a fully contextualized timeline. So that's the explanation. Martin, Brenda, what are your
I was going to add there.
Go ahead, Brenda.
I was going to add there, Paul, where, you talk about it's such a big task for one person, right? In terms of adding that context, and I even lost engagement some days because it's that notion of every day I have to go and I have to, those micro stops and record the duration as well, right? And a lot of their activities I used to do it was pen and paper in terms of even recording the downtime and then using a stopwatch. So when it goes back to it's such a big body of work. And this is where you start getting, the clarity of can I even trust the data? Because, it's subjective a little bit as well in terms of how I'm doing the recording. And then as well as when you look at the challenge of engagement, right? What misses a lot with the tools that I've worked with was nobody thought about the operability. I stay engaged when I'm very excited about something and it makes sense and I can see the impact and the result that it's bringing on. And we often forget to ask that simple question when we're trying to deploy the technologies. So I think, one of the things that I could speak later on as well is with what we do at Raven, I've had that opportunity to see how just providing a tool that makes sense and that's easy to use. So I appreciate when I started my career, I worked in the auto, the first 6 weeks of you starting your career, regardless of what role you're going to do, you work as an operator because it's so important for you to live a day in the life of, so that when you're bringing on those technologies, you bridge that gap of engagement.
Yeah, and it's about doing it in real time as well. So I bet sort of stopwatch activities were maybe done after the fact, where something had happened, you needed to investigate, because you certainly wouldn't be sat there proactively necessarily waiting for something to happen. And it's doing it in real time that I think the real sort of focus.
One of the things to just when back when I was in manufacturing prior to co-founding Raven, I think one of the things that I always felt was that I was missing kind of that real-time guidance to where the important problem was that I should be solving. So my approach when I was a supervisor, had 50 operators, was to walk very quickly around, and then I'd catch a lot of this. So, and often what happens is that, so the kinds of contexts that sort of fit into that bucket of items that we would ask operators to tag is often the context that we won't be able to get through digital systems. So, and I'll use just a comparison here. So, I'm sure you guys have used Waze. I don't know, Paul and Brenda, if you use Waze for navigation.
Yeah,
so
it's actually
Waze,
a really great example.
it's great. So no, but one of the things with Waze is that a lot of what it does, it's a navigation tool, and it takes in traffic data and historical patterns to guide you, and let you know where to go. And on occasion, it'll ask you for context. And the kinds of context that people provide are, there's a police officer right over there. There's a giant pothole. So if we look at the data or look at performance, the performance could be traffic is deadlocked. Traffic is running slowly. And that is performance. And that we're able to get performance from digital systems. But the context, why has traffic slowed down to a crawl? Where there's a police officer right here. What? One lane is closed because of a giant pothole, because we live in Canada and springtime is full of potholes. So I think that context also exists in a manufacturing setting. So an example of this was, we had one client, manual packing line, and to reduce labor, they were every hour getting the packer to take the pallet of goods and move them over to the warehouse, which took them about 3 minutes. So every hour, productivity would slow down, and there's about 10 people at the table that feeding this packer. So of course, productivity would tank. And the reason for this was they were waiting for the packer to get back. So if you just look at productivity, that 2-minute dip would just get averaged out. But the fact is, there was a fundamental issue, and the human context was they had a process that involved the end of the line going to the warehouse for 2 minutes every hour. So that's the kind of context that that provides tons of value, not to measure performance. And I think there was a question about, OEE and which metrics matter. In some ways, what matters is the ability. What we need is the ability to identify the root cause of the loss. And the root cause, you don't get that by measuring performance. You get that there by understanding the true nature of the inefficiency. And I'm wondering, Paul, just from out of sequence now, are we closing in on teeing up the second poll, or?
I think we're good for the second poll. Yeah.
Okay, so so we've been talking a lot about categorizing the reasons for downtime. If things are producing, we can get that from our digital systems, but when things aren't producing, it's not always easy. So for those of you who work in manufacturing, have experience, what is the biggest barrier to collecting accurate downtime reasons? And again, we'll try to answer the questions ourselves without influencing the crowd too much. But okay, first, lack of buy-in from operators. Operators just aren't willing to give us the context. Second one, it's not feasible for them to tag it. There's no way, no tool. They're too busy. Operators don't have any method to actually provide this context. They're willing, but no method. And the last one is just, there should be sensors. We just don't have those sensors. So, it says host and panelists cannot vote. So I guess we can only vote with our words. We can't click buttons. All right. So Brenda and Paul, maybe jump in here. Which of those are top of mind for you based on your experience?
This one's tough because it's a mix of all of these, right? But I think when it comes to the collection, I will pick on the necessary tools, right? Because it drives the engagement. It just drives the ability on how quickly you're able to do it.
Yeah, it's an interesting question or poll this, because there is an experience I had where I was told that we can't tag contextualize the data because we just don't have the sensors. We just don't have the sensors to be able to create 100% timeline. That plant now, I think, is up to 80%, 70 to 80% actual contextualize and increasing all the time. So if people are checking lack of sensorization, we should definitely have a conversation, because sensorization is not necessarily the solution to this.
Which is interesting, because that's in some ways, many manufacturers are seeing IoT as the path to enable improvement through digital transformation, and there are some sensors that measure what operators do, but there aren't yet sensors that can sense, what operators are seeing and the context for the problem. So I think that's a key thing. So yeah, number one, operators don't have the necessary tools and lack of buy-in. I would start off with the lack of buy-in, but I guess, based on our experience at Raven, I've seen, there is ways to get buy-in from operators if you present them with a tool that provides them value. And tools that provide operators value is not one that shows them OEE, not one that shows them metrics that they cannot influence. So what is useful to operators is anything that they can do to influence the organization to fix problems that are meaningful to them, either in the moment. So if they're waiting for the packer to come back, telling us that context, triggering an alert to go out that the packer needs to come back, that's of value. Seeing that they're ahead or behind of production. So I think there's things here where you can get buy-in from operators if you understand that technology has to provide more value to them than it consumes their time. And that transaction is critical. And when you get that transaction right, you get the buy-in. And I think for the necessary tools, that's what we obsess over. And we have a tool that provides this value, and I'm more than happy to dig into that here later. So this is probably a good transition to kind of the last section for our presentation today, where Brenda is going to describe what this actually means on the shop floor. So we've talked about the problems, the reasons for the problems, the theory around, what can be done. So now, Brenda will dig into, so what does this look like on the shop floor? How does this actually provide value to manufacturers today?
Absolutely. And, I'm going to I was looking at some of the questions and comments that are coming in from the audience. And one of them is really, it touches on how do we motivate the operators to care about adopting the technology? The other comment that came in was around the design reliability issues that are often misunderstood as a result. And we categorize that as it's equipment failures versus it just wasn't designed right. So one of the advantages, I think, that and the privilege that I have with my team is we get to see how we're solving some of these challenges through the contextualized timing. So a great example, a few weeks ago, we're kind of, self-reflection with the team there, where we're looking at the case studies that we've been able to deliver with what we're doing at Raven. And we had a customer that was struggling to keep up with demand and dealing with, labor constraints are real with some of the pandemic challenges that we've seen impacting the supply chain. They didn't have the visibility to the accurate data on the production line. But within a month of us deploying our tools and collecting that automated contextualization, they were able to have that solid baseline of the current shop floor operations. Because just even understanding what is the output on a basic start of the week can I actually attain? So really quickly within a week, they started to really understand and see what are those capabilities. With the guidance that the team provides as well, we were able to provide the insights on the improvement areas with simple actions that we started off with, such as standardization of ways of working across shifts. We often don't even think about that because we don't have the data, but a lot of the times, once you see that real-time visibility of that timestamp Paul was talking about earlier, Martin, right? It's, all my customers, when they're able to compare exactly the operations of all the 3 shifts, it's so easy to action that because we can give you that detailed timestamp of the changeovers on shift A. They're making the same SKU on shift A, takes 30 minutes longer. So just drilling down to changing those simple behaviors has really enabled a lot of our customers to be able to drive productivity and action it really fast. So Paul kind of talked about when I'm using my stopwatch, it's an after fact, right? Where I have to wait a period of time before I can gather the insights. With this real-time notion where you're able to see everything, it's pretty much instant because within a week, you can start to action it. Another example that we're starting to see as well when it comes to their contextualization is their ability for an operator knows their equipment. I mentioned this earlier on. They want to make sure that it's operating correctly. So having them have the visibility to the data in terms of what's happening is really driving a lot of their engagement because, a lot of operators will see that I'm not meeting my target case output as an example, and then they're able to see the activity of every asset on their production line and quickly action it instead of waiting until the end of the shift to be able to drive activities.
There's a question sort of come up here that it's a really important one, and what I know it's from. Yeah, I think the end of it is OEE is myopic, and technology that focuses on that metric is failing to see the real challenge. And I think the conversation of OEE is a critical one. And I think there's kind of like 2 camps. One is OEE is the thing, or it's maybe there's a new thing coming here. And in some ways, I think the key thing is that you didn't mention OEE once in what you were describing. You were describing the fact that operators understood what was happening. And I think that, again, I'll go back to what I mentioned earlier, which is the goal of applicate these kinds of technologies is to make it easier for our problem solvers to identify and solve problems more quickly. And you solve problems when you identify the root cause. So, an OEE is a framework that's been used for a long time to pull in data from different systems and allow for us to get a feel for where the problems are. But in many cases, it's rather than being used as a tool to identify problems, it's been being used as a tool to gauge how good or bad you are. So I would say that there's nothing wrong with the idea of having a roll-up metric like OEE to capture performance or relative performance, but that's not an effective tool to actually enable problem solvers. So, it's the same data feeds into both. So the data that we get from our contextual timeline can be fed in to create the OEE metrics that are understood by manufacturers. And I think it's important to not stray so far away from the fundamentals that people become uncomfortable, but measuring OEE is not what actually drives improvement. OEE going up is a consequence of being effective at identifying and solving problems more quickly, which is really the focus of what we do, and many companies that are in our space that are focused on improvement rather than simply demonstrating the capabilities of technology.
Yeah,
100%.
Go ahead.
Always just telling operators that they're constantly losing doesn't help, particularly if there's no context there. If there's just a red screen saying you're behind target with no context on exactly how to improve or even explain why they're behind target, then that's problematic. What context allows you to do is just reframe that. So it's no longer just, you're losing. It's okay, maybe you're not quite running to target today, but you did, yesterday. And the reason you're not running to target today is because, you've been waiting for materials for a particular asset. And so that being captured then, now the operator knows that there's a reason there that's being communicated through the chain as to exactly why there's a loss, rather than it just being some large bucket that's a catch-all.
And that's a critical thing here. And I think what we'll do here is we'll open things up for questions shortly. So if you have questions in the audience, now's the time, and we'll open up Q&A in very, very shortly. But I think to sort of respond to that point here, constantly having a red screen saying that you're not performing is not a compelling experience. And there's theories behind what actually creates a compelling experience for operators or anybody being provided performance feedback. And one of them is that if you're presenting somebody with feedback, make it actionable. So if the operator is shown a red number, they can do something to make it green. If operators don't, if they're presented with OEE for their line, or departmental quality, these corporate metrics, which capture how performance, it is demotivating to show them things that they can't impact. And I think that's one of the things that we've learned in developing our systems. There is theory behind what actually drives engagement, and it's by presenting meaningful metrics to operators and presenting them in a way that they're actually able to influence them to move in the right direction. So I think as we sort of transition to the Q&A section, just to sort of sum things up here, many manufacturers today are embarked in digital transformation, and there's some bumps along the way. And what we're seeing from our clients, and what's actually and most reassuring, is that a lot of the things that manufacturers need to do to get value from digital transformation is very similar to the fundamental things that they did to drive improvement in the past. Step one, do you know what's happening now? Do you know what's happened in the past? If you know that, take this data and you can analyze it to understand why. Once you understand why, predict what's going to happen in the future, and then take action to make sure that things go in a better direction. And that action could be operational. That action could be new process. That action could be buying software or technology. But that fundamental process of deriving value from data is the same with or without technology. And I think once we realize that continuous improvement hasn't changed, and this is simply a new tool, that we still start with people, put in good process, and then add tools. Technology is in the tool section. It's reassuring to many manufacturers that they don't need to relearn how to improve. And really, when deployed properly, these tools should enable more rapid continuous improvement.
I'd go one step further as well, Martin. I'd say if you've got that context and you've got the data, you can automate a lot of that process you've just described as well. Move away from having to drill down. If the context is there, you can automate the analyze and even start prescribing action. I mean, that's ultimately what prescriptive analytics needs. It needs context.
Absolutely. So, and just before we jump into Q&A, so helping manufacturers unlock improvements. The improvement potential of their people is what we live and breathe with technology, is what we live and breathe at Raven. If you would like a personalized tour showing how our software can provide value in your plants, feel free to click this. We're not going to show the results of this survey, but this is just a way for us to link back in. And of course, feel free to reach out to any of us here. Okay, so now we're going to jump into the Q&A section. So I know we have a bunch of live questions, and I guess Lindsay, just let us know which screen we should go in first. And I guess we can go from the top here. Yeah, you know what, we can go from the top, and then, so thanks to everybody who's answered the poll, and I'll now flip to Q&A, and we'll just sort of take them one at a time, Brenda and Paul. So I may put you on
one that really popped up, because this is one that I hear a lot all the time, is one of the challenges to capture OEE speed loss. It's hard to capture, many variables, constant changes. How do you see this issue as part of automated contextualization? So this is a problem all my customers have, and Martin, you're nodding because it's a real pain point, but that's something that we do really well. So that ability for us, as we talked about on machine learning and our AI capabilities, right? That is one of the things that a lot of my customers, when we're driving insights for them, we've actually been able to show them that, majority of your losses are actually coming from those speed losses, because no one is tracking anything that's not running below that target rate. But we have the ability to actually pull that data out and be able to action it with the customers.
That's right. And there's a difference between running slowly and micro stops, and then a stop where something else has happened. So to be able to figure out which ones you need to ask questions to the operator and which ones you don't is sort of critical. And absolutely, speed loss is that hidden loss that often sneaks in there and could have a massive consequence. So we've answered the question about, okay, there's a question here about, what are some of the motivation, what are the metrics that operators care about? And I would say that in the moment, operators do not care about OEE. The kinds of things that operators care about is to understand if they are on track or not, to have a reminder of where they are in their process. So the things that we put in our operator interface relate specifically to things that we have learned that operators get value from. And that value that they get is part of that transaction that I talked about earlier. They need to get something that is obviously useful to them so that they can then provide us with context. And we need to give more than we receive. There's a question here. Once accurate data is available, is there a step-by-step approach you would recommend for organizations going from not trusting data to utilizing data accurately and efficiently while avoiding analysis paralysis? So there's actually two parts to this. One is how do you actually get the good data, which I think is kind of what we discussed earlier. But the other one is on trust, which I think is an important thing here. And I think this is one that, trust is something that's earned. And, when you've lost trust of the shop floor, when you go down to the shop floor and the look in the eyes of operators when you're asking them, so what do you think about that 80-inch screen? And they kind of roll their eyes. So I think trust is earned. And for operators, they're less interested in reporting than action. And the kind of actions that they want to see is, if they are interacting with their system, are they seeing evidence that they're able to influence their organization to do things to address their problems? And that kind of evidence would be, when they interact with the system, are they seeing that their supervisors are being more responsive to requests for support? Are they seeing that maintenance is coming to fix their machines more quickly? Are they seeing that their leadership is making decisions about process changes and technology purchases that actually addresses things that they have raised? So I think that's the key thing. And once, trust is going to be re-earned when they see that this data and technology is actually leading to actions that's making lives easier for operators on the front lines. Another question here. And I don't know if you, okay, so besides tracking if they are on track or not, can you give some more examples of data operators care about and what you can show them. I don't know, Brenda, if you have any examples here that come to mind. I know we have a bunch of different things.
I think in terms of some of the, you touched on the key ones that we see very often. It's they know their equipment well, they know how the operations should be running. They just simply need the actions to happen. So one of the key attributes, is we do empower the operator, because I can go and ask an operator a question in terms of the context, and depending on my relationship with that person, the answer could be different, but through the way we get the operator context through our technology, they're able to give you that honest answer. So a lot of the times, a lot of my successful customers, they're actioning quickly in real time some of those issues that the operators are putting together. And what I've often seen as well, which is interesting, is when it comes to metrics, everybody's a little bit of a competitive spirit. So some of my successful customers, it's like the operators and the supervisors are kind of like having this competitive attribute across all three shifts, because they've been able to drive that level of engagement. So you tend to see that if one shift is actually driving the OEE is 85%, then the next shift coming in is going to try and beat them, because now we're able to give them also information to communicate at the end of shifts. So changeovers in terms of shift to shift are a little bit more transparent in terms of what were the issues that happened on that day shift. And that's such a game changer, because no one's walking in blindly.
Oh, absolutely. And I think that's kind of the thing for those of us who've, worked in manufacturing. You come in at 7 a.m. or 6 a.m. on a Monday, and you're like, what just happened? And to be able to answer that question without having to go around and do your 2-hour investigation. Yep. And I think that's something that you can see. And for those of us who are, who want to know ahead of time, we can, take a peek to see what has happened before we, go into the plant on 6 a.m. There's a question here about, why, why couldn't I simply go and walk up to an operator? Why is your machine not cutting metal? And I think, what is the value of having technology to do this versus, managing by walking around? And I think that highlights an important thing here where, without question, if we had, way more supervisors walking the shop floor, management by walking around is highly effective. The challenge is nowadays our supervisors are stretched very thin and have even less capacity to spend time on the shop floor. And this is something that I think, many manufacturers are trying to maximize that time, but the time of our leaders has been spent more, and in many cases being consumed by technology that's pulling them away from the shop floor. So our ability to go and ask those thoughtful questions to operators about what is happening is limited. And the way to complement and not replace, because you do not want to replace leaders going on the shop floor, but the way to complement, what leaders should be doing, which is seeing all their operators and having those interactions, is giving operators the tools to send that context through other methods and ways that, again, provide more of a sense to leadership, what they should be spending their time on.
I'd also add maybe something that we've missed out, that context is actually more than just, the machine is down because it's waiting for a material. Other additional sort of context is, what SKU is the machine running, what shift is on, who's the supplier for the material that's being used, what tooling's being used. And when you combine that context with the context that we've been talking about, that's when you then can look at performance on very many different dimensions. You may find that for a particular asset SKU combination, performance or the frequency of microstops or certain types of problematic downtimes has been very persistent. But when you've got possibly dozens of assets producing hundreds of SKUs across different materials suppliers, etc., no human being can sort of view where that particular loss is and to be able to prioritize it. So the contextualization feeds into a broader context that then feeds into analytics that then can find the key losses that humans can't find. But as Marty said, we're not trying to replace the Gemba walks and just walking around the factories.
Yeah, and at some points, I think we need to. One of the ways to enable better performance is to enable our problem solvers to spend all their time solving problems, which is to get them away from their desks, get them away from analyzing and manipulating data, and spending time with each other on the shop floor. So that's the end of our hour here. And I know that for those of you who want to keep going, I know that Lindsay and the marketing team will be doing a recap and a Q&A that they'll be posting and sharing on our blog. We're also going to share that on social media channels. Brenda and Paul, this has been fun. When's the next one? Next week?
I know the hour did go by fast, and I know we can keep talking, so we got to be conscious of everyone's time.
Yeah. and I appreciate all of the questions that came in live, the questions that came in beforehand, and all the engagement. Maybe one of these we'll have one where folks can come up on stage here. But yeah, so thanks all, and to get in touch with us. There's our website, email address. You can also find Paul, Brenda, and myself on LinkedIn. We're all super friendly. So if you send a connection request, we will accept. Thanks everybody.